Alright, this is Unit 15 for conchem. We're going through the review, and this is question number 5. So for question number 5, it's asking for you to write a dissolving equation for an ionic or a covalent compound. Actually, they want to know what's the difference between them. So I like to start with covalents because I find covalents to be the easiest. The thing about covalents is they don't split. So it makes them very, very easy. In other words, the compound is the same before and after the actual dissolving process. So for example, if we want to dissolve a covalent compound such as sugar, which is C6H12O6, that's glucose. Alright, it's a solid crystal. When we dissolve it in water, it still is going to be sugar. So it's going to be C6H12O6. Only now it's going to be aqueous instead of solid because it's dissolved in water. But notice the formula never changed, nothing changed about it. Covalents never change when they dissolve. They look exactly like they did when they were dry before they were dissolved in the water. Now ionics are different. They split. So when we look at an ionic compound, what we're going to see is an ionic compound like calcium chloride, for instance. Okay, ionics always split. And specifically, they split into ions. And you're going to get a cation, which is the positive, and an anion, which is the negative. So this is where you have to pull on those memories you have about the ionic unit when you had to calculate or determine the ionic charge of a particular ion. So in this case, calcium, it's a group 2 metal, so meaning it's the second column from the left. Group 2 metals always have a charge of +2. Chlorine is a halogen, so it is a group 17 nonmetal, meaning it's second from the end. They always have a -1 charge. So when this splits, we're going to get calcium ions that have a +2 charge, and we're going to get chlorine ions that have a -1 charge. Now there is a trick here that will work most of the time, and what that trick is that you can look at the subscripts. So in this case, calcium has a subscript of 1. Notice that matches the charge of the other ion, in this case chlorine. And if we look at the subscript here for chlorine too, that matches the charge of the calcium ion. Because the ionic compound, the overall charge has to add up to be 0, this will always be the case. The only time this is different is in a few scenarios where you reduce the charge. But generally speaking, you can uncrisscross it to determine the charges. Once you have your charges, now we can actually write the formula. So in this case, we would say that we had solid calcium chloride. We're going to dissolve it in water. And now we're going to get the cations and the anions. So this is where those charges come into play. We have our calcium, which is going to form our cation. And then we have our chlorine, which is going to form our anion. They're both going to be aqueous because they're dissolved in water. They were solid before, but now that we've dissolved them, they're aqueous. And then the last step is we have to follow the law of conservation. The law of conservation says that the amount of products has to equal the amount of reactants. So notice on the left-hand side we had 1 calcium here and we had 2 chlorines. I'm getting that from their subscripts. Okay, calcium actually has a 1 subscript. So on the left-hand side we have 1 calcium and 2 chlorines. That means on the right-hand side we need to have 1 calcium, which is what we have, and then 2 chlorines. Okay, so that gives us our formula for an ionic compound. The big thing to remember is covalents never split. They're the same before and after. Ionics do. You have to split them into their ions.